Welcome. So we're going to go through this lesson, which is application of circular functions, which will involve our CAS calculator. But our first example doesn't need the CAS. This graph shows the height of the tide in Evergrove for the first 12 hours after midnight. Here it is here. What we need to do is deduce a sine model, which will represent the height of the tide in terms of t hours after midnight. Okay, let's see how we go here. The first thing I'm going to do is just kind of identify some key features here. So what is my amplitude going to be? Remember, your amplitude is how far above the center of the graph it's going. So it actually might be more helpful to figure out the vertical shift that is occurring here first, because we know there is a vertical shift happening because the graph, as you can see, is not centered around 0, it's rather centered around 4. Here it is. So that means I've got a vertical shift of +4. Once I've got that, now it's a bit easier to see what my amplitude is going to be, because the amplitude is this distance right here. So it's from the center up. So it's 4 till 7 and then 4 down to 1. So obviously the amplitude here is going to be 3. I also need to identify what the period is going to be. Remember, the period is how the distance it takes for it to do one full cycle. So what is that going to be? So to do one full cycle here, I'm going up, down, and up. So that means one period is 6. One period is 6. So that means the period here, when we come to write it down, is 6. Okay, now with all of this information, let's write down what our general form of the sine equation would be. So height is equal to A, which is my amplitude, sine, B, which is going to affect the period, T, because remember it's in t hours, plus C, which is the vertical shift. Immediately we can write in the easy stuff. We know that the amplitude is A, which is 3. Sine, let's leave this B here for a second because that's a bit tricky. And then plus C is going to be +6, because, oh sorry, +4, because I've got a vertical shift of 4. Now we need to figure out what this B is going to be. It's not as easy as just chucking 6 in here, because remember, the way in which you find the period of something, if you've gotten the coefficient of t, is you go 2 pi over b, and that gives you the period. So in this case, we know it's going to be 6. So therefore, we need to solve for b. So that means b is going to be what? It will be 2 pi on 6, which is pi on 3. So take note of the little step we had to do there. It wasn't as simple as just chucking in 6. We had to say, well, 2 pi over the coefficient is going to be equal to 6. Therefore, b is going to be equal to pi on 3. So my final answer here is 3 sine pi on 3 t plus 4. So just a nice little trick there. Well, not trick, but procedure to make sure you're getting the right answer. So that is the first part of our question there.